Hello everyone. Welcome to this detailed presentation on calculating the area of a triangle using trigonometry. In this video, we will explore the different formulas used for finding the area of a triangle when the triangle's sides and angles are known. Let's dive into the principles and step-by-step methods to master this topic. To start, let's understand the basics of calculating the area of a triangle. The area of a triangle is the measure of the space enclosed by the triangle. In geometry, this can be calculated in several ways depending on the available information. For trigonometry, we use certain formulas when angles and sides of the triangle are involved. Let's break these down. Today, we're going to explore a fascinating topic in trigonometry, the area of a triangle. Triangles are one of the most fundamental shapes in mathematics, and understanding their area is crucial not only in geometry but also in real-world applications like engineering, architecture, and even art. Before diving into the formulas themselves, let's take a moment to appreciate why calculating the area of a triangle is so significant. The area represents the space contained within the triangle's three sides. It's a measurement of how much surface the triangle occupies, which is an essential concept for solving problems in various fields. Triangles come in all shapes and sizes: right-angled, equilateral, isosceles, and scalene. Each of these types might pose unique challenges when calculating their area. But here's the beauty of mathematics. Over the years, mathematicians have developed different methods to determine the area of a triangle depending on the information we have at hand. For example, what if you only know the base and height? Or what if you know the lengths of all three sides but no angles? Or maybe you have two sides and the angle between them. Each of these scenarios calls for a specific approach to calculate the area. In our session today, we'll be unraveling these different methods, each tailored to solve a particular problem. Whether you're dealing with simple measurements or complex geometries, there's always a formula to guide you. So, get ready to dive into the world of triangles, where precision meets creativity, and where every corner holds a unique mathematical story. Let's get started. Now, let's explore these methods step by step and see how they can help us calculate the area efficiently. The first one is area formula using base and height. The most common formula for the area of a triangle is when you know the base and height. This formula is expressed as area is equal to 1/2 times base times height. This formula applies to all triangles, and it's the foundation for many other formulas we'll explore. However, trigonometry helps us derive alternate formulas that are useful when angles and sides are known. The base is any one side of the shape that serves as the reference for measuring height. The height is the perpendicular distance from the base to the opposite side or the vertex. If dealing with a triangle, the height must always be measured at a right angle to the base. Key points to remember include ensuring that the height is always measured perpendicular to the base and that both the base and height are in the same unit of measurement for the formula to work correctly. The formula can be adapted to different shapes by understanding the relationship between their geometry and the base height concept. By applying this formula, calculating the area of various shapes becomes straightforward and efficient. The next one is area formula using two sides and included angle. The area of a triangle can be calculated using various methods. One particularly useful formula involves two sides of the triangle and the angle between them. This is known as the area formula using two sides and the included angle. Now, this formula is used when you know two sides and the included angle between them. It's expressed as area is equal to 1/2 times A times B times sine C. Here, A and B are the two sides of the triangle, and C is the angle between them. This formula is derived from the basic formula of area but incorporates the sine function to account for the angle. This is how we get the formula for the area when two sides and the included angle are known. This formula is particularly useful in trigonometry when working with non-right triangles. The formula relies on two sides of the triangle and the angle between them. The sine function is used because it relates the ratio of the opposite side of a right triangle to the hypotenuse, which simplifies calculations for non-right triangles. This formula is derived from the general trigonometric relationship in triangles and the concept of decomposing the triangle into right triangles. When we multiply by, we effectively account for the height of the triangle relative to one of its sides. The angle must always be the one between the two given sides. The sine function ensures that the area is proportional to the shape of the triangle, no matter the size of the angle. This formula is especially useful when the height of the triangle is not known but the two sides and the included angle are given. It can be applied to all types of triangles: acute, obtuse, or right. This formula is an essential tool in trigonometry, simplifying the process of finding areas in cases where traditional height-based calculations are impractical. Next, let's discuss another formula, which is Heron's formula. Heron's formula is a mathematical method used to calculate the area of a triangle when the lengths of all three sides are known. Unlike other area formulas that require the height or angles, Heron's formula is particularly useful in cases where such information is unavailable. In this formula, A, B, and C are the sides of the triangle, and is the semi-perimeter, calculated as A plus B plus C divided by 2. The semi-perimeter helps in simplifying the calculation of the area without needing the height. These terms represent the difference between the semi-perimeter and each side of the triangle. To use Heron's formula, first determine the lengths of all three sides of the triangle and label them as A, B, and C. Next, calculate the semi-perimeter, S, using the formula S is equal to A plus B plus C divided by 2. Once is found, apply Heron's formula for the area, which is given by area is equal to the square root of S times S minus A times S minus B times S minus C. Substitute the values of S, A, B, and C into the formula and calculate step by step. Begin by finding s minus a, s minus b, and s minus c, then multiply these results together. Finally, take the square root of this product to determine the area of the triangle. The resulting value represents the triangle's area. Heron's formula is widely used in geometry, surveying, engineering, and various real-world applications where determining a triangle's height is impractical or impossible. Heron's formula provides a versatile and efficient way to calculate the area of a triangle based solely on the side lengths. This makes it a valuable tool for solving complex geometric problems. The last one, which is area in terms of circumradius. Now, let's look at the formula that involves the circumradius of the triangle. The circumradius r is the radius of the circumcircle, the circle that passes through all three vertices of the triangle. The area can be calculated as area is equal to a times b times c over 4r. This formula uses the product of the sides a, b, and c, and the circumradius r. It's useful in certain advanced problems, particularly in geometry and trigonometry competitions. The area of a triangle can be calculated using various methods, depending on the given information. One particularly useful formula expresses the area of a triangle in terms of its circumradius. This formula is derived from the relationship between the circumradius, the sides of the triangle, and its area. This formula is a result of combining the standard area formula for a triangle with the properties of the circumcircle. Basic area formula. The area of a triangle can be expressed as 1/2 times a times b times sine c, where c is the angle opposite side c. Sine rule. According to the sine rule, sine c is equal to c over 2r. Substituting this into the basic area formula yields the following key points are: applicability. This formula is valid for any triangle, regardless of whether it is scalene, isosceles, or equilateral. Circumradius r. The circumradius is specific to the given triangle and is dependent on the lengths of its sides and the arrangement of its angles. The formula is particularly useful when the circumradius and the side lengths of a triangle are known, as it provides a direct link between the geometry of the triangle and its associated circumcircle. Additionally, it serves as a concise and elegant method for calculating the area of a triangle in terms of the circumradius, highlighting the interconnectedness of the triangle's geometric properties. To provide an engaging and comprehensive overview of the concept of triangle areas, why it's significant in various applications, and its relevance before delving into examples and solutions. Triangles. They are one of the simplest yet most profound shapes in the world of mathematics and geometry. But have you ever wondered how this seemingly simple shape holds such an important place in our everyday lives? Today, we will embark on a journey to explore one of the fundamental properties of triangles, their areas. Before we dive into examples and calculations, let us first understand the importance of this concept and the different scenarios where the areas of triangles come into play. The study of triangles dates back thousands of years. From the Great Pyramids of Egypt to the intricate designs of medieval cathedrals, triangles have been a cornerstone of architectural brilliance. Ancient mathematicians, such as Euclid and Pythagoras, laid the groundwork for understanding the properties of triangles. Among these properties, The concept of calculating the area of a triangle was pivotal for construction, land division, and even astronomical calculations. In today's world, the area of a triangle extends far beyond the realms of architecture. Engineers use it to design stable structures, surveyors rely on it to measure land accurately, and graphic designers incorporate it into digital art and modeling. Triangles, with their inherent simplicity, form the backbone of complex systems, from computer algorithms to artificial intelligence models. Before solving examples, it is essential to familiarize ourselves with some basic concepts about triangles. Triangles are polygons with 3 sides, 3 vertices, and 3 angles. They come in various shapes and sizes: equilateral, isosceles, scalene, right-angled, obtuse, and acute triangles. Each type has unique characteristics that influence the methods used to calculate its area. For instance, the formula for a right-angled triangle might differ from that of a scalene triangle. Understanding the area of a triangle isn't just about solving textbook problems, it's about solving real-world challenges. Consider a surveyor determining the area of a triangular plot of land, or an engineer designing a bridge where each component forms a triangular structure. The ability to calculate areas efficiently and accurately can make all the difference. At its core, the area of a triangle depends on 2 key measurements: the base and the height. However, not all triangles make it straightforward to identify these dimensions. For example, in obtuse triangles, the height often lies outside the triangle. For triangles without a clear height, methods like Heron's formula or trigonometric approaches come into play. These foundational principles will guide us through various examples in this session. Triangles are everywhere around us. Take a moment to observe the world. You'll notice triangular shapes in the sails of a boat, the roof of a house, or even in the design of your favorite art installation. Each of these real-world triangles has an area that can be calculated and analyzed. But how do we do it? What are the steps involved? And what challenges might we encounter along the way? These questions will be answered as we proceed with examples and solutions. One cannot overstate the importance of precision when dealing with triangle areas. A small error in measurement can lead to significant inaccuracies, especially in professional fields like architecture and engineering. Visualization tools, graphing methods, and digital software can aid in ensuring accuracy and efficiency. As we explore examples, we'll see how these tools can be applied to achieve reliable results. Now that we have laid the groundwork, we are ready to explore examples that demonstrate the calculation of triangle areas in various contexts. From the simple to the complex, these examples will illuminate the versatility and importance of this fundamental concept. So, let's dive in and begin solving. Remember, the triangle, with its 3 sides and 3 angles, is more than just a geometric shape. It's a key to unlocking a deeper understanding of the world around us. Let's take the next step in this fascinating journey and see the magic of mathematics in action through examples of triangle areas. Today, we're going to learn how to calculate the area of a triangle using the base and height. This is one of the most common ways to determine the area, and it's an essential concept in geometry and real-life applications. By the end of this session, you'll be able to solve a sample problem step by step and explain your solution confidently. Let's begin. Here, the base is one side of the triangle, and the height is the perpendicular distance from the base to the opposite vertex. Let's solve a problem together to understand this better. A triangle has a base of 10 centimeters and a height of 6 centimeters. Find its area step by step. The first step is to identify the values given in the problem. Here, the base is 10 centimeters. That's one side of the triangle chosen as the foundation. The height, 6 centimeters, is the perpendicular line from the opposite vertex to this base. Does everyone see how we identified the base and height? Remember, the height must always be perpendicular to the base. Next, we write down the formula for the area of a triangle. This formula means that we multiply the base and height, and then take half of the result. Now, we substitute the values of the base and height into the formula. We replace the base with 10 centimeters and the height with 6 centimeters. Now, we're ready to calculate. Does anyone have questions about how we substituted the values? Let's calculate step by step. First, let's multiply 10 times 6, and the result is 60. Lastly, multiply the 60 by 1/2, so the result will be 30. The area of the triangle is 30 square centimeters. This is the total space inside the triangle. Does everyone understand how we calculated the area step by step? Let's summarize the process. To recap, we solved the problem by following 4 steps. First, we identified the base and height. Next, we wrote down the formula. Then, we substituted the values into the formula. Finally, we performed the calculation step by step. We're going to learn how to calculate the area of a triangle using a special formula. Area is equal to A times B times sine C. This method is particularly useful when we don't have the base and height but know 2 sides and the included angle. By the end of this session, you'll understand how to use this formula through an example problem, step by step. A and B are the lengths of 2 sides of the triangle, while angle C is the angle between those 2 sides. Let's solve an example to see how this works in practice. A triangle has sides. A is equal to 7 centimeters, B is equal to 10 centimeters, and an included angle C is equal to 60 degrees. Find the area of the triangle step by step. The first step is to identify the given values in the problem. The 2 sides are 7 centimeters and 10 centimeters. The included angle between these sides is 60 degrees. These are the values we'll substitute into our formula. Does everyone understand how we identified the given values? Next, we write down the formula we'll use to calculate the area. This formula works when we know 2 sides of a triangle and the included angle between them. It's an alternative to the base height formula. Now, we substitute the values of A, B, and sine C into the formula. We replace with A with 7 centimeters, B with 10 centimeters, and the angle C with 60 degrees. Now, let's calculate the area step by step. First, multiply 7 and 10. The result will be 70. We now have 70 multiplied by sine 60 degrees. The result shown was 60.62. Next, calculate the 1/2 multiply 60.62, and we get the final answer, which is 30.31. Does everyone understand how we perform each step? To recap, we followed several steps to calculate the area of a triangle using the given formula. First, we identified the provided values, including side A, side B, and angle C. Next, we wrote down the formula to ensure clarity and accuracy. Then, we substituted the given values into the formula. Finally, we performed the calculation step by step to arrive at the correct result. To summarize, we've covered several key formulas for finding the area of a triangle in trigonometry. These formulas include: area is equal to 1/2 times base times height. Area is equal to 1/2 times side A times side B times sine C. Area is equal to the square root of ES's times ES's minus A times ES's minus B times ES's minus C. Area is equal to A times B times C divided to 4R. Each of these formulas is valuable depending on what information you have about the triangle. Whether you know the sides, angles, or circumradius, you have the tools to calculate the area effectively. Thank you for watching. Make sure to practice these formulas and apply them in different problems to solidify your understanding.